In this chapter 8 of mathematics, we are going to see application of integrals. In application of integrals, we are mainly going to see how are we going to find out the area of any particular section under the curve. So now, yes, I'm stressing on this point, under the curve. Why? Because if you're going to find out the area of any geometrical figure, let it be any polygon or let it be any triangle or under any line, it will be very easy for us to calculate. But when it comes to the curve, let it be a parabola, cubic curve, or any other curve, it will be difficult. So in order to understand that, application of integration is going to help us out. So now let's try to understand this in depth. So in this particular part, we are just going to see a basic introduction. Why are we going to use this application of integration, or what is the use of integration while looking in terms of finding out the area of a particular plot or a particular diagram? Let's have a look into this. You can see here, now this application of integrals or any integration part over here, it is a branch of calculus whose focus is mainly on solving real life world problems and analyze the various situations. Now, what is that real life world problems we are talking about? Let us assume you have got a plot of this dimension like this. So here is a line, and here also is a line, and here also we have a line, but on one side there is a curve. Now, how are you going to find out the area of this particular plot? It is going to be very difficult, right? So now, in order to understand that, we will try to understand a small infinitesimal small area over here. So what I'll do is I'll just draw a straight line over here, and I'm going to draw another straight line. Now, if you're going to look into this, this looks like a rectangle because this is having a small width, this is also having a small width, along with it we have a length. So now if you're going to consider this small area, it will be very easy for us to solve. Why? Because we are going to take it as a small area and it is considered as a rectangle. So rectangle, we can take it as length into breadth, but can it be applied overall? Yes, it can be applied, but if you keep on taking very small values, but which is not possible. So for that, we are going to take out integration, taking out the limits from the minimum to the maximum and going to solve it. Now, what is this integration? Integration is basically a combination of infinite number of infinitesimal small values. So it's nothing but a combination of all those small rectangles so that we can take out the area in a single click. So now this is about finding out the total accumulation. Total accumulation is nothing but taking out the total area. Next, the main application is finding the area under the curve, which we are going to discuss in this particular chapter. In the next part, we are going to look into completely how to solve or how to find out the area under any curve. Similarly, if you're going to look into circular section over here, you might be knowing the area of the circle where based on the triangle or based on the trigonometry, you might be able to solve it. Or if you're going to look into this particular equation, what if it is not exactly in the form of a circle? What if it is in the form of an oval? What if it is in the form of an ellipse? Okay, so at that particular time, you're going to find out this area under the curve. Let it be over x-axis, let it be over y-axis. Based on that x-axis or y-axis or based on particular definite interval, we are going to apply and we are going to write out the answers. So let's move on to the next part and we will understand how are we actually going to find out the area under the curve. Thank you.